All right, so last quadrilateral that we're going to talk about is a kite. And the thing that makes a kite is that it has four sides and it has two pairs of, I have the hiccups by the way, consecutive congruent sides. My kite kind of looks more like a rhombus here, but you'll get the idea as we go. So that is one thing, and you can draw it or you can write it. Two pairs of consecutive congruent sides. But like the rhombus and the square, it has a pretty cool property for its diagonals. And the diagonals in a kite don't ever actually look super diagonally, but they are. The diagonals of a kite are perpendicular also. And remember, that means perpendicular, and perpendicular means that they intersect at 90 degrees. And the other property is that there's one pair of opposite angles that are congruent. And it's these. Be careful when you're looking at your diagrams. Only these are congruent. All right, there's no other properties. It's just these three. Two pairs of consecutive congruent sides, which is really what makes a kite a kite. Diagonals are perpendicular, which creates a whole bunch of opportunities to use the Pythagorean theorem or trig, and one pair of opposite angles that are congruent. All right, let's do some examples. ABCD is a kite. Find the measure of angle B and the measure of angle D. These, angle B and angle D, are what I was talking about when I said that opposite angles are congruent. There's one pair. And something you may not know, but you may have heard, is that quadrilaterals have 360 degrees on the interior. One way to kind of visualize that is to look at it as two triangles. There's 180 in that triangle and 180 in this triangle. So there's 360 degrees total. So I'm going to do 360 minus 85 and minus 43. That's going to kind of give us our leftover amount. So we have 232 degrees left in our kite. And these angles, the opposite angles, are congruent. So all we have to do is divide that by 2, 116 degrees for angle B and also angle D. I hope that that makes sense. Please let me know if it doesn't. KJLM is a kite. Find the measures of angle M and angle K and angle J. Well, we know that the opposite angles are congruent. So if L is 82, then J has to be 82. And we also know that a quadrilateral has 360 degrees. So 360 minus, and I'm just going to add all those up, 235. So angle K equals 125. So that's just kind of the arithmetic side. Let's look at the algebra side. URST is a kite. Find the measure of angle STV. So this is the angle that we want. Now there are many, many ways you can look at this. I'm going to talk you through the first one that pops into my head. There are other ways though. So I know that in a kite, the diagonals are perpendicular. So I'm going to focus my attention right now simply on this triangle here, which is a triangle, and how many degrees are in a triangle? 180. So I'm going to say 9x plus 1 plus 23x minus 7 plus 90. Don't forget that 90. Three angles add up to 180, the triangle angle sum theorem, equals 180. Now we're going to simplify this guy. Let's see, 90 minus 6 is 84. I just combine like terms. So x equals 3. But we want to know the measure of this angle. Well, this angle, 9x plus 1, would be 9 times 3, which is 27, plus 1, 28 degrees. And isn't this an isosceles triangle? Yeah, it is, because those are congruent, consecutive congruent sides, and that means that these base angles must be congruent. So angle T, or STV, has to be 28 degrees. Are there other ways to figure that out? Absolutely. This is the way that popped into my head right now. All right, let's keep trucking. AC, this is a kite, by the way. I just didn't kind of write that there. AC is 38 and ED is 41. And we want to know CD. We know in a kite that diagonals are perpendicular, and we know this is 38. This diagonal does actually get cut in half by the other one. It is bisected. So 38 divided by 2 is 19. And now, do you see what I see? Hopefully you see the Pythagorean theorem. So I'm going to do 19 squared plus 41 squared equals, I'm just going to say DC squared. And take the square root of both sides. So DC is approximately 45.2 units long. All right, now just so you can kind of see it, what if I had asked for this angle measure? Can you think of any way we could find that angle measure? Hopefully you said a little trig action. There's a triangle. I have this angle, the opposite side, and the adjacent side. So which trig function would that be? Tangent. So tangent of x, we don't know the angle, equals opposite over adjacent. When you're looking for the angle measure, remember, use the inverse tangent. And make sure your calculator is in degree mode. Mine is. So I'm going to do second tangent, 19 over 41, 24.9. So this angle right here is 24.9 degrees, which means this angle is 24.9, and we could go on and on and on and do other various trig things to figure out the rest of this triangle or kite. All right, good luck with the practice, and let me know if you have any questions.